finishing up this third page. Again, I told you that other one. Concavity, that means I'm looking for second derivative. Now, to make this go a little easier for derivative, since there's only an x in the bottom, instead of having to do the low d high, I am choosing to rewrite it like this. So my first derivative is -3 times -1 times x minus 5 raised to the -2 times 1. Or in other words, it's going to be 3x minus 5 raised to the -2 power. That is my first derivative. So now going on to solve for my second derivative, the 3 stays down, it comes down in front, negative times -2, x minus 5 to the -3 power, which is the same as -6 over x minus 5 to the third power, and that's my derivative, so I'm going to set that equal to 0 over 1. Oh, look at when you cross multiply, nothing happens. And undefined, oh, look what happens. I get x minus 5 raised to the third power equals 0. So cube root each side, x minus 5 still equals 0. X would equal 5. So on my function f of x compared to f double prime of x, the only thing that I have to test is left of 5 and right of 5. So if I put 0 and I plug it into my second derivative, I get a negative divided by a negative. That's going to be positive. That's concave up. It's going to look like a cup. If I put 10 in, this is going to be positive divided by a negative. It's going to be negative. This is going to be concave down, going to look like a clown. So they asked, where is this concavity concave down? From 5 to infinity. Okay, so continuing on, asking where this is increasing. That is first derivative. This first derivative is a product rule. X times 1/2 of 12 minus x squared raised to the -1/2 now, times -2x. So all of that first derivative of second added on to the second term times the derivative of the first. Okay, so cleaning this up, and hopefully you guys can see this 2 and this would cancel. I have a -x and a -x, so I'm going to get a -x squared all over 12 minus x squared raised to the 1/2 power, added on to 12 minus x squared raised to the 1/2 power. That's my derivative. I'm going to set it equal to 0 over 1. When I have 0 over 1, or 0, I'm going to get something. If I did 1 over 0, not going to work, so I'm not worried about that. So just like I did earlier, I am going to take a term and move it to the other side. And when I do that, I get -x squared over 12 minus x squared raised to the 1/2 power equals a -12 minus x squared to the 1/2 power. At this point, you need to think about cross multiply, and 1/2 times 1/2 is 1. That works awesome. So I'm left with x squared equals -12 minus x squared. So I'm going to take this negative sign plus negative plus, and I'm going to subtract that, and I just lost myself again, and I have to apologize. This had a negative hooked onto it and I dropped it, so this has a negative hooked onto it because I knew it was supposed to work out. So when I do this, I get -2x squared would equal -12. x squared would equal 6. X is going to equal plus and minus the square root of 6. So on my chart, and I told you room is hard, f of x and f double prime of x. These don't want to work out very nice. In terms of decimals, it's negative 2.44 and it's positive 2.44. So when I figure that out, this region here is going to be decreasing, or it's negative. When I plug in 0, it is positive, so it is increasing. And when I plug in 5, it is negative, it is decreasing, and this is single prime here. So the question asked, where is it increasing? It's increasing from negative 2.44 to positive 2.44. Okay, won't try to let myself get distracted anymore. Somebody just knocked at the door. We're going to let that go. So increasing, decreasing, first derivative. So y prime equals 10x minus 3. Set it equal to 0, I can work it. When I set it to 1 equals 0, it's not going to happen. So x is going to equal 3 tenths. So in my graph, f of x compared to f prime of x, I have my 3 tenths on there. So I'm going to pick a random number such as 0, plug it in, I get a negative, which is decreasing, and when I plug in 5, I'm going to get a positive, which is increasing, and they asked where is it decreasing from negative infinity to positive 3 tenths. And finally, inflection points. Inflection points are from the second derivative. Okay, so let's take a derivative and work it out from there. So my first derivative, when I bring the 3 down, it's going to give me 2x to the second minus 4x. When I take the second derivative of that, it's going to give me 4x minus 4. When I set that equal to 0, I can work it out. 1 over 0, guess what? Not going to work. X would equal 1. So now in my function of f of x compared to f double prime of x, I put 1 in the middle. I test any point that I'd like. I'm going to test 0. I'm going to test negative 1. When I put negative 1 in here, my answer is negative, so this would be concave down. It's going to look like a clown. When I add in positive 1, when I look at positive 1, it gives me, oh, I have to apologize. This is 1. When I look at positive 2, it gives me a positive number. This would be concave up. It asked, is this an inflection point? That's where it changes from concave up to concave down. Yes, x equals 1 is my inflection point. So, hopefully this helps.